Welcome. At this session, we are going to discuss about separable differential equations. So remember that if the right-hand side of the equation dy dx equals to f of x, y can be expressed as a function of phi and let's say psi that depends only on x times a function phi of y that depends only on y, then the differential equation is called separable. So in other words, we are saying that dy dx can be written as product of psi x times phi of y. So if this is the case, then this equation is separable. Now to solve such an equation, we simply take x variables to one side and then y variables to the other side and then integrate. For example, if I have dy dx equals to 2x plus xy over y squared plus 1 is separable since f of xy, which is 2x plus xy over y squared plus 1, is equals to x into 2 plus y over y squared plus 1, which can be written as x 2 plus y over y squared plus 1. So which is equals to psi of x times phi of y. So in this case where the function that depends on x is x, and the function that depends on y is 2 plus y over y squared plus 1. But however, the equation dy dx equals to 1 plus xy is not separable. I remember the easiest way to try to do conversion to check whether the equation is separable, is just to do factorization and see if it is possible to express the right-hand side of dy dx as a product of two functions, one in terms of x, another one in terms of y. So to solve the equation dy dx, which is a function of x and y, that can be written in this form we multiply by dx and by h of y, which is given by 1/5 of y, to obtain h of y times dy equals to phi of x times dx. Then integrate both sides. This means we have integral of h of y dy equals to integral of phi of x dx. So i.e. capital H of y will be given by g of x plus c as our final solution. Now let's demonstrate how we solve such kind of equations. So examples. Solve the following differential equations. Solve the initial value problem dy dx equals to negative x over y, subject to y at 4 is minus 3. Now, to solve this solution, note that dy dx equals to negative x over y. We can write it and multiply through by y, so y dy equals to negative x dx. Now integrating, so we have integral of y dy equals to minus integral of x dx. So this follows that y squared over 2 equals to negative x squared over 2 plus c. Let's say c1. So multiply through by 2 will have y squared equals to negative x squared plus 2c1. And then I can say, let's see, to be 2c1. Or I can call it, I can write this one as y squared plus x squared equals to 2c1. So I can say, let this constant be just a square, so that I have x squared plus y squared equals to c squared. So when I replace, when x is 4, y is given as minus 3. That's why we have the condition y at 4 is minus 3. So we'll have 4 squared plus minus 3 squared equals to c squared. So 16 plus 9 equals to c squared, which implies c squared equals to 25, which implies c is 5. So reason as to why we picked our constant here we wrote this one as c squared is because when we see y squared plus x squared equals to a constant, then this tells us that probably we are dealing with the equation of a circle. So then equation of a circle, we know in general form is given so that this constant is a square, which defines the radius. So therefore, x squared plus y squared equals to 5 squared, or x squared plus y squared equals to 25, which is a circle of radius 5. Next question, number 2. Solve dy dx equals to e raised power minus x divided by y. Now what we do here, we cross multiply. So we'll have y dy equals to e raised power minus x dx. Then integrate. We'll have the integral of y dy equals to the integral of e raised power negative x dx. Now, when you integrate y, you get y squared over 2. This will give us negative e raised power negative x, and then plus a constant, say c1. So which means y squared equals to minus 2 e raised power minus x plus 2c1. So we can say let d be the same as this 2c1. So which means y squared equals to minus 2 e raised power minus x plus d, which implies y equals to plus or minus square root of d minus 2 e raised power minus x. So that would be the solution to that question. And next question, solve, that's number 3. Solve the nonlinear equation dy dx equals to x minus 5 over y squared. So here we cross multiply so that we have y squared dy equals to x minus 5 multiplied by dx. Then integrate. We'll have the integral of y squared dy equals to the integral of x minus 5 dx. So it'll be y cubed over 3 equals to x squared over 2 minus 5x plus c1. So which can be written as y cubed. So multiply everything by 3. So it'll be 3 over 2 x squared minus 15x plus 3c1, which we can say let 3c1 be c, so that we have y cubed equals to 3 over 2 x squared minus 15x plus c. And you can make y the subject by saying y equals to 3 over 2 x squared minus 15x plus c raised by power 1 over 3. So next question, number 4, solve dy dx equals to 3x squared e raised power minus y, subject to y at 0 is 1. Now, we'll first multiply through by dx. So we'll have 3x squared e raised power negative y dx. And then divide through by x by e raised power negative y, so that we have dy over e power negative y equals to 3x squared dx. Now this gives us e raised power y dy equals to 3x squared dx. Now the equation is separable. So then integrate. So e raised power y dy, 3 integral of x squared dx. So this will be e raised power y equals to, now these 3 will cancel out so that we have x cubed, then plus c. Now, y at 0 is given by 1. So which means that when we put e raised power 1, so x is 0, then plus c. So this tells us that c is e raised power 1. So therefore, e raised power y is equals to x cubed plus e. Or introducing ln on both sides, we'll say y equals to ln of x cubed plus e as your final solution. So I'll give further examples in the next class.